Alright, so Unit 2, Section 2.2 examples. Powers of 10. So before we get into some examples using the powers of 10, I'm just going to explain quickly what a power of 10 is and something interesting about them. So here are some powers of 10 from 0 to exponent of 9. Do you notice anything interesting about these? Look at the pattern. Yes, the zeros go down by 1 as the exponents go down by 1. But do you notice anything else that's very interesting? Look very closely at the exponent and at the number of zeros. Did you notice the exponent also represents the number of zeros when written in standard form? So for example, let's look at 10 to the power of 0. This equals 1. 0 means nothing's there. How many zeros do we have? None, because it's 1. Let's look at 10 to the power of 1. How many zeros do we have? We have 1. What's the exponent? 1. 10 to the power of 9. We have 9 zeros and the exponent is 9. So we can say that the exponent also represents the number of zeros when written in standard form. Another interesting thing is we can use these powers of 10 to write any number. So let's try one. Let's use the powers of 10 to write the number 1, 2, 3, 4. Let's break down 1, 2, 3, 4 into some expanded form. So 1,234 is also equal to 1,000 plus 200 plus 30 plus 4. As we examined on the last slide, 1,000 can be written as 10 to the 3. Or, as we all know, any integer can be written as 1 multiplied by itself. So in this case, we have 1 times 10 to the 3. We also examined on the last slide that 100 can be written as 10 to the 2. But in this number, we have two 100s. Therefore, we have 2 times 10 to the 2. Again, in the last slide, we examined that 10 can be written as 10 to the power of 1. In 1,234, we have 3 10s. So we write 3 times 10 to the power of 1. And then finally, we have 4. As we examined before, 1 can be written as 10 to the 0. But in this case, we have 4 1s. So 4 times 1, or 4 times 10 to the 0. So our answer comes out to 1 times 10 to the 3 plus 2 times 10 to the 2 plus 3 times 10 to the 1 plus 4 times 10 to the 0. Now you try. Try to write 5,023 as a power of 10. Give you the first step. Break it down as I did for 1, 2, 3, 4. So you get 5,000 plus 20 plus 3. Now we know that 1,000 can be written as 10 to the 3. In this case, we have 5,000s. So we write 5 times 10 to the 3. Because we don't have any hundreds, we don't have to worry about writing 0 times 10 to the 2 because we know that everything times 0 is 0. And when we add 0 to something, it is just itself. So we just ignore writing that. And we have two 10s, and as we know, we write 10 as 10 to the power of 1. So we have 2 times 10 to the power of 1 for our 20. And finally, we have 3 1s, so 3 times 10 to the 0. So 5023 written as powers of 10 is equal to 5 times 10 to the 3 plus 2 times 10 to the 1 plus 3 times 10 to the 0. Now, the reason why we have the equal sign is because if we did all the multiplication and addition in our answer, we would come out with the original number. So therefore, we have to, and I will repeat, have to have the equal sign because that number is equal to the original number. So, exponent laws. There are multiple, and we'll get into more later, but right now we're just going to examine one. And it's the power of 0. So any power with an integer base, except for 0, knowing that integer means any number, and an exponent of 0 is equal to 1. So if I was to put any number to the exponent of 0, it will equal 1. So let's examine a few numbers here. 10 to the 0, 4 to the 0, 999 to the 0, and negative 3 to the 0. Do you remember back in elementary school how any integer can be written as itself multiplied by 1? So for example, 7 equals 1 times 7. Well, let's look at that. 7 is actually 7 to the power of 1 because we're multiplying it by itself one time. As you remember, in section 2.1 we said that an exponent is the representation of repeated multiplication. So if we have 7, that's 7 to the power of 1, meaning we're only multiplying it one time. So we have 1 times 7. So if we think about 10 to the 0, looking at the left side of your screen, 10 to the 0, we will have 1 times 10, but we actually don't have any 10s multiplied. We have 0 times multiplied of 10. So we actually only have 1. Same goes for 4, same goes for 999, and same goes for negative 3. Now, if we look at negative 7 to the 0, does this equal 1? Many of you are probably thinking right now, yeah, but actually, this is not true. Do you remember in section 2.1 how we talked about if you do not have brackets, the 0 only applies to the number and not the negative sign? Well, same goes for here. So, negative 7 to the 0 is actually equal to negative, inside parentheses, 7 to the 0, which actually makes us have the answer of negative 1. So for any number that looks like this, so if we have negative 9 to the 0 without brackets, we will still end up with negative 1. So always be careful and examine a negative. Is there brackets or is there no brackets? Is the negative inside or outside of the brackets? If it's outside, you get negative 1. If it's inside, you get 1.